Good morning everyone. We're here now at our Physics 121 class. I'm Claude Signori, and here we are. We're gonna have an experiment number 3. The app that we use for today is Proto. Here in Proto, you can build, simulate, and learn about electrical circuits. Signal analysis and oscilloscope, learn by examples, and modify components values, and lastly, many components to use. Now let's get started. What is a series circuit?
So, series circuit. Series circuit is a circuit in which resistors are arranged in a chain. So, the current has only one path to take. The current is the same through each resistors, and series circuit is also defined as having only one path through which current can flow.
Now, what about parallel circuit?
A parallel circuit comprises branches so that the current divides and only part of it flows through any branch. The voltage or potential difference across each branch of a parallel circuit is the same. But the currents may vary. In a home electrical circuit, for instance, the same voltage is applied across each light or appliance. But each of these loads draw a different amount of circuit according to its power requirements. A number of similar batteries connected in parallel provides greater current than a single battery, but the voltage is the same as for a single battery.
What is series parallel circuit? In a series parallel circuit, there is combination in series and parallel, and the voltages across each of the components is the same for the parallel. And the series parallel circuits are typically used when different voltages and current values are required from the same voltage source. Without further ado, let's start our experiment. Now here's the Proto or app. Then let's try to add the source. Now here. Now let's add 3 resistors. Since we are tasked to have a series circuit with 3 resistors. So let's reverse it now. Now let's locate these resistors to their places. Before that, let's change the voltage into 10 volts since it is given. Now let's place it. Now let's change the values since we are tasked to have 3 resistors with different values. So we have 2 kilo ohms for the resistor 1 and 3 kilo ohms for the resistor 3. Now let's connect. Now we can see the circuit is running now. The current is running now. So you can see here the flow of the circuit slowly. Now you can see in the resistor 1 we have 1.67 milliamperes, same as the 3 resistors. Since we are series, so we can say that the current for the 3 resistors are the same. So we have different voltage drop for the resistors. So 3.33 volts for the resistor 1. Now let's see what if we change this resistor value to 100 kilo ohms, what will happen? So we can see here that there will be no movement or flow of current will be stopped since it will resist the current. which passes through, and it affects the other resistors since it is series circuit or connection. Let's change it again to 2. Now we have 9.62 volts. So now let's have the voltmeter. Let's So the voltmeter will be, if used, is it should be parallel to the resistor. So now let's test if how much value the voltmeter will have. So 3.3 volts, same as the resistor 1, which is the voltage drop is 3.3 volts. So it's correct. Then let's try to check the um, resistor 2 by the voltmeter. Now let's connect it with the parallel, the same as parallel. Then we have 1.67 volts or 1.7 volts, same as the volts we have in our voltmeter. So that is how we check if how many volts we have for the resistors. So now for the resistor 3, we have 5 volts. So it is the same as the resistor 3. So the values have been satisfied with our values of the resistor and what we have get in our voltmeter. Now let's try ammeter. So the ammeter will be connected in a series way. So let's delete this one. Then let's connect it in a series, since the ammeter should be connected in a series form. Now let's look. So we have 1.7 milliampere. So it is expected to have 1.7 milliamperes since this is a series circuit. And in a series circuit, the current that flows in these three resistors have the same value. Since it is 1.7, then we will have universal value, which is 1.7 for the current which is flowing through the circuit. So now let's look closely what will happen if we change this resistor 3, the value of it into 100 kilo ohms. So what will happen? So we can see here the concept of the series circuit, how it affects the other circuits. Now we have here, we can see here that the current is not running anymore since it is resisting the current. And in a series circuit, this is the concept of it, that a resistor affects the other, unlike the parallel. That's why series circuit is not much applicable for our home appliances. Now let's move on to our second task. So I have here the parallel circuit with three different resistors, with three different values of resistors. So we're gonna add our source, voltage source. So let's change it into 10 volts. You can see here now. Then we have added three resistors. Now let's place it. Since this is a parallel circuit, we will place them in a parallel way. Unlike the first first circuit that we have already been taken, which is series. So now let's change the values into 2 ohm. Since we are tasked to have different values for the resistors, we will change them into 3 different values. Now we can see here that we have one for the resistor 1, 2 for resistor 2, and 3 for resistor 3. So the current is running now. So the current is running on the 3 resistors. So we can, in this task, we can see the concept of the parallel. So um, let's use the ammeter. Let's use ammeter, then connect it in a series way. Let's delete this one, then add this ammeter. So for this one, since the ammeter is placed near at the endpoint for the circuit, the 3 resistor will be added to have the value of this ammeter. If you add the resistor 1, 2, and 3, we will get the current which passes through the on the ammeter, since um, the flow of current was way directly to um, the place where we place our ammeter. Now we can see here that the current that passes through this ammeter is resistor 2 and resistor 3, which means if you add the resistor 2 and resistor 3, we will have the 8.3 amperes. So this is the concept of a parallel circuit, which means that with one of the um, so, resistor fuses, the others will still play their role, or stay will still play or run the currents. So we can see here that we have the 3.3 ampere, just like what we have the value in our resistor 3. So now we know why we use parallel circuit in our home, since one appliance does not affect the other. So we added here the voltmeter, then connect it in a parallel way. So the value that we will get is the same as the value that passes through these resistors. Since in a parallel circuit, the values will be the same for every resistors. Now we have 10 volts, which is the same for the resistors. Now for our third task, we will have a series parallel circuit. So we'll add the source. Let's change it into 10 volts. Now let's add 3 resistors. Let's add 4 to have a series parallel circuit. So we decided to have this kind of circuit. So still in this circuit, we will have 3 different values for the resistors. So let's change the values of these resistors. So let's change in 2. So 1 ohm and 2 ohm for resistor 1 and resistor 2 respectively. Now let's add our fourth resistor. This changes into 3 ohms and 4 ohms for the resistor 4. So we can see now that the current is flowing in the 4 resistors. Now we can see here that in the resistor 3 and resistor 4, there is the same value for the current, since it is a series connection, and therefore they will have the same value for the current. Now this time let's use ammeter. Let's add ammeter. Now we have it. Let's connect it in a series way. Now we can see here that there is 3.5 ampere. Um, if we add the resistor 1 and resistor 3, the current that flows in them, we will have the 3.5 ampere which flows in the ammeter that we have placed a while ago. So same goes as this one, ammeter in this one. So the current that passing through is from the resistor 3, so it is the same value. So for a while ago, so the two resistors adds up to the ammeter value that we have, since they flows in the same way ammeter was being placed. Now let's add the voltmeter in a parallel direction. So we can see here that they have 7 volts for the resistor 2, same as the voltage drop in it. So let's have it in the resistor 4. Let's try to check if it's the same. So for the voltage drop of the resistor 4, it has 434.78 ampere, same as what we get on the voltmeter. So let's connect it in the resistor 3. So this is how we connect a voltmeter. It should be in a parallel in a connection. So to sum it all up, in the series circuit, the concept of it is that when one of the resistors get a problem, it affects the other resistors, and thus if it does not work or fuses, the circuit will, or the current flowing in it will not pass through or flow at all, since in a series circuit it affects the other kind of resistors. So now in the series circuit, we have the same value for currents, and that's why this series circuit is not ideal for home appliances. To have an example, if one of our appliances, example of that is let's say electric fan, and it is connected in a series circuit with our bulb, and if our electric fan get a problem and fuses or does not work, the bulb also does not work, and it will be a problem. So that is one of the concept of the series circuit. So for the parallel circuit, on the other hand, so we have the same value of voltages across the resistors, and in a parallel circuit, um, it does not affect the other resistors since it is connected in parallel manner. So that is why this is the ideal or the most common circuit that we can observe in our home, since it does not affect any other appliances. So the parallel circuit is a great example of a circuit that should be applied in our home to not manifest any problems whenever there is a problem on one certain appliance. So on the other hand, for the last but not the least, which is the series parallel circuit, this is the combination of the two circuits, which is the maybe the simple series circuit or the parallel circuit, and the parallel circuit. And we can see here that the connection here, we have here a parallel and a series at the same time. So to get the if you're asked to have the voltages or voltage drop for the resistors or current, we will have to narrow down this circuit. And that will be all. Hope you learned something, and see you in our next video.